When I wrote my book, I titled it 7 Easy Steps to CNC Programming, and I chose that title for a reason. The 7 steps to CNC programming are basically, number 1, you have to determine how are you going to make the part. You'll need to know your appropriate speeds and feeds if you're cutting a part or machining a part, or you're going to need to know the speeds and feed for which you can deposit material if you're using a 3D printer and depositing material on a platform. You're going to need to know your fixturing. How are you going to hold the part, or where are you going to put that part on the 3D printer platform? You need to know the order and sequence of each one of your operations so that you can do them in an ordered manner so you don't put a big hole where a small hole belongs. You also need to know the number of programs and setups that are going to be required to go from the drawing to a finished part. You will need to know the machine limitations, what it can do, maybe how big the cube you're working with is. You can't put a great big part in a tiny little machine. And you also want to certainly keep in mind any safety considerations that could in some way damage the human being or damage a part or something, or just a tool. The second step is you need to make up a list of the tools you tend to use, because the tooling you use is going to make a difference in how you program the part. If you have space limitations, you might be using a small tool to go in a large area. Well, that means you're going to have to make more passes. Or on the other side, you might have a really large tool and an open space where you can use it, so then you can take a few less passes. But all that needs to be determined before you begin to make the part. And step 3, you make a setup sheet and you define the tool or cutter paths as they relate to a program origin. Now when we start talking about rectangular coordinates and Cartesian coordinates, you'll know that there's a part origin. So then what you do is you make a setup sheet, and that setup sheet will reflect each one of the tool points where the tool moves, changes direction, does a rapid travel, or whatever. And you do this because this step organizes your thinking, and it provides an operator, if someone else is going to be operating the machine, with a description of how you intend to run or make the part. So that when they push that button, they're not surprised at what it does. You can kind of prepare them by giving them the setup sheet and what's going on with the machine. Step 4 is you write your program using your setup sheet. And the reason you do this is it keeps the process organized, and it gives you a reference to go back to if you get interrupted. And if you're working in a shop with lots of people around, or you're working in the home, in a garage, you've got lots of kids around, or dogs, or cats, or neighbors coming by, it's pretty easy to get interrupted, and you don't want to forget something important. Step 5 is you proofread your manuscript. In other words, after you write your manuscript, whether you type it or write it by hand, however you do that, you want to proofread it and look at it and try and catch any mistakes, or what we call desk check it. Because the safest place to catch a mistake is right there on paper before you actually commit the machine to making a part of any kind. The 6th step is you actually load the program you wrote into the machine. You might load it in using a USB drive. You might load it in using a floppy disk. Some machines still use floppy disks. Some machines use direct or distributed numerical control, where a computer actually talks specifically to the machine or directly to the machine, and the programs are sent from the computer to the machine without a human having to touch them. And the 7th step is, once that program is loaded in the machine, you want to look at it, make sure it loaded properly, didn't drop anything, and it's one last opportunity to kind of check and see what's going on before you push the button to make sure it's safe and nothing's going to get damaged or broken, or just simply waste a bunch of time cutting air. So let's get started here in just a second.